Okay, so this is going to be a video explaining this homework, 7.2 WSP. Now, there are some typos. So how about right now, stop what you're doing and let's recopy number 25. There was a mistake. The original one says r to the third, but that should be a -2. So you're going to have to rewrite the whole thing like this. Okay? And if you're wondering, if you look at the back side of your worksheet that has the answer, the question is different. So if you don't make this change, you're obviously not going to get the same answer that they have on the back side of your worksheet. So please make sure you change number 25. Change the r to the 3 in the denominator to an r to the -2. So this is what we need to do, have an r to the -2 down there. Then when you work it out, you'll be able to get the same answer. Also, number 27 has a typo. Actually, 27 is just completely wrong. Okay, I don't know why, but on the worksheet it came out as something completely wrong. If you look at the back side of your worksheet on the solution section, 27 has a completely different question. So inside you're going to have 2x to the third, y to the second, z over 3x to the fourth, y, z to the -2. And it's all to the -2 power. So this is way off. I don't know what happened. Maybe the people that created the worksheet, they just, I don't know, they weren't paying attention. They put a totally different problem right here compared to the solution side. So please make that change. That way you end up with the right answer on the solution section.
Wait, what did you change?
So let's jump to number 1. Now, how many 8s do I have on the bottom? 4. How many 8s do I have on the top? 8. So obviously, if I were to expand it 8 times 8 times 8 times 8, 4 times, and then 8 times 8 times 8, 8 times up on top, 4 8s, all of these will completely cancel with 4 of these, and obviously we'll have 4 left over. So the answer is 8 to the 4th power, but you're supposed to simplify. If you have a calculator, simplify it. I think it's like 4,096 or something like that. But is it 4,000? What is it? 4,096. It's not. I just remember the answer on the backside. That's why I don't know that 8 times 8 times 8 times 8 is 4,096. But you could leave it like this: 8 to the 4th or 4,096. On the quiz, I will want you to completely simplify. On the test Friday. I'm sorry, not quiz. Okay, so a lot of students have asked me, well, what about the bottom? This completely canceled out. Don't you need to put a 1 down there? And the answer is no. You don't need to put a 1 down there. Why not? Because anything divided by 1 is the same thing, right? So 8 to the 4th power, or 4,096 to the 4th power, not to the 4th power, 4,096 divided by 1, that's still 4,096. Or it's still 8 to the 4th. So whenever you divide by 1, you don't need to put the divided by 1. Okay? So for example, let's say you're working on a problem. Let's go over here to the side. Let's say you're working on a problem. Let's say you had 2 over 2 to the second. Well, there's 1 2 up here that will completely cancel out with one of these. So what do we have left? There's nothing left up on top. So you need to put the 1 up there. So when everything cancels from the top, you need to put the 1. And on the bottom, you still have 2. Because you can't just say, oh, I'm not going to worry about this 1, I'm going to erase it. The answer is not 2. The answer is 1/2. Now, but if it was the other way around, like let's say you had a 2 to the 3rd up here and a 2 squared down here, then yeah, this cancels with 2 of these and you'll have 1 left. So you really have 2 to the 1 over nothing. So right here, you don't need the 1. Okay, because 2 divided by 1 is what? It's 2. So you don't need to put the divided by 1. So let's get that clear, guys. When everything cancels up on top, you have to put the 1. When everything cancels on the bottom, you don't really need to put the 1. Because 2 divided by 1 is just 2. You could just put whatever you have without putting it over 1. But like I said, if everything cancels out up on top, you have to put the 1 up on top. Yeah? Okay, let's move on. Number 2. This is all about canceling, guys. It's rule on the board. It's rule 7. You have A's on top and A's on the bottom. So 1A cancels out with one of these. You're going to have 3 A's left. There's 3 B's on the bottom and 6 B's up on top. So all 3 B's, that's why I put a line all the way through the 3 and the B, because there are no more B's. All those 3 B's canceled out with 3 of these 6. so I will have 3 left over. So my answer is a to the third, b to the third, and yes, I could put over 1, but is it necessary to put the over 1? No, it's not, because divided by 1 will give you the same exact answer. So let's not put this divided by 1. Let's just leave it a to the third, b to the third. That's your answer. And that's how they write it on your solution on the back side. Let's move on to number 3. There's an x up on top, and there's an x on the bottom. So whenever you have x divided by x, that completely cancels out. There's no more x's, right? What's 5 divided by 5? 1. What's 10 divided by 10? 1. What's y divided by y? 1. So right here, x divided by x, it's 1. So we just cancel it out. And then the y's, well, I have 1 y down here. That'll completely cancel out with one of these two, so I have 1 left. So what's my final answer?
Y.
Y. Now you could put y to the 1 over 1, but that's totally pointless because y to the 1 is just y, and divided by 1, it's just y. So your answer is just y. Let's move on to number 4. What could I cancel out, guys? The m's, okay. How many m's are on the bottom?
4.
How many are on the top? So 4 of them cancel with 4 of them. All 4 m's on the bottom cancel out with 4 of the 5 up on top. How many are left up on top? 1. So I could put a 1 right here if I want. Could I cancel out n with anything? No. How about p and p? Yes, those cancel, which means that they disappear. This p and this p, they're gone. So what's left over? M to the 1, and I don't even need to write m to the 1. So just m, and also n. That's what's left over up on top. M and n. Now there is nothing left on the bottom, so it's pointless for me to put it over 1. I could if I wanted to. It's not wrong if I put it over 1. But we already know that anything divided by 1 is the same exact thing. So we're going to leave it as mn as your final answer. Yay?
Yay.
Okay, number 5. Could I cancel out this 5 with this 4? No. What could I cancel?
The C.
The C. There's 2 C's up on top, and there's also 2 C's on the bottom, so they completely disappear. They become 1, right? So if you wanted to, you could put 5 times 1, but what's the point of that? It doesn't change anything. So I would just scratch them out. They're gone. And now the D's, well, there's 1 D on the bottom that cancels out with one of these. How many are left? 2. And they're left up on top. So let's rewrite what we have as our final answer. There's a 5 up on top. There was a negative 4 on the bottom. And what else is left? There's a D squared up on top. And that's it. Now, normally, the better looking answer would be to take this negative sign and just put it right in the middle of the fraction. So the best looking answer is to put the negative in the middle of the fraction, 5D squared over 4. That's the best looking answer. I mean, of course, this is totally right, but the bottom one's a better looking answer. Let's move on, number 6. I could cancel what? I could cancel out y's, but I could also cancel out the 8 and the 4, right? This is really saying 8 divided by 4. What's 8 divided by 4? 2. Now let me show you an alternate way of looking at it. You could say instead of 8, I'm going to rewrite the 8 as 4 times 2. Now why would I do that? Just so you could see how this 4 cancels out with this 4. It disappears. That's just an alternate way of doing it. If you already know that 8 divided by 4 is 2, then you're good. But you could change it to multiplication so you could see the 4 cancel with that 4. And of course, there's going to be a 2 left over as a coefficient up on top. And now we move on to the y's. Well, there's 7 y's up on top, 6 y's on the bottom. All 6 y's cancel out with 6 of these 7, which means I have 1 left over up on top. And there's 5 z's on the bottom and 6 z's up on top. All 5 z's cancel out with 5 of those z's, so I have 1 left over up on top. So our final answer, I could put it over 1 because there's nothing left on the bottom, but our final answer is a coefficient 2, because that's what we have left over, and then y to the 1, and then z to the 1, z to the 1. Now we don't need these powers of 1. They're invisible. You could erase them. So that's what I'm going to do. I'm going to erase the powers of 1, and I'm also going to erase the divided by 1 because that's pointless. So my final answer in simplest looking form, the best way of making it look would be 2yz. Move on to number 7. So on number 7, there's many rules that we could apply. We have parentheses with an exponent on the outside. So you could distribute that power to each and every term, or you could zoom in on the inside of the parentheses and see if you could do anything. Now obviously on the inside there's nothing to cancel. If you had an F and an F, then you could cancel out F's, or a G and a G, but you can't. Everything's different. So the only thing to do is to distribute that 3 to each and every exponent. So first recognize that the ones that don't have exponents, they have the invisible 1, and then we're going to distribute. And when we distribute, you multiply a power to a power. So my answer, I'm going to rewrite the fraction, and I'm going to rewrite what I have so far. I'm going to have 4 to the 3rd power. And then when I distribute 3 times 3, that'll give me F to the 9th power. And then when I distribute 3 times 1, that'll give me G to the 3rd power. And then when I distribute on the denominator 3 times 1 down here, that's going to be 3 to the 3rd. And then 3 times the 6, that's going to be H to the what? 18th. Great. So right here, the only other thing we could do is simplify 4 to the 3rd and 3 to the 3rd. So 4 to the 3rd is not 12. 4 to the 3rd is really 4 times 4, which is 16, times 4, that's 64. And then F to the 9th and G to the 3rd. And on the bottom, we have 3 to the 3rd, which is not 9, it's actually 27. 3 times 3 is 9, 9 times 3 is 27. And then H to the 18. And that's your final simplified answer. There's nothing else to reduce, there's nothing to cancel. Let's move on to number 8. Number 8, again, I would look for the inside and see if anything could cancel, but there's nothing to cancel. W, P, R, nothing cancels. Now, if I had a W to the 3rd down here, yeah, I could cancel out W's. But since they're all different variables, I can't cancel out anything. Also, I would look at the coefficients, 6 and 7. There's nothing to cancel, there's nothing to reduce, but sometimes you might end up with like 6 over 12. Then you could reduce that to 1 over 2. Or maybe 14 on top, 7 on the bottom. Then the 14 divided by 7 would be 2. So sometimes you are able to cancel out coefficients or reduce. Right here you can't. So there's nothing to do inside the parentheses. We move on to distributing. So when I distribute the 2, I put it on the 6. That'll be 6 squared. The 2, right there with the 5. 2 times 5 is 10, so you have W to the 10. On the bottom, 2 with the 7 is going to be a 7 squared. 2 with the 6, multiply them, that's going to be a P to the 12th. 2 with the 3, multiply it, it'll be R to the 6th. And the only other thing you could do is 6 squared and 7 squared. 6 squared is 36, W to the 10th. 7 squared is 49, P to the 12th, R to the 6th. That's your final answer right there. Number 9, what could I cancel? The X's. How many X's are up on top? 2. How many are on the bottom?
5.
So X to the 3rd will be your answer. Like, think about this. All 2 X's cancel out with 2 of these 5. There's going to be 3 left over. Okay? So far on my answer, if I put equals, I'm going to have an X to the 3rd on the bottom. There's no more X's left up on top. Now, 4 over 24. Okay, now the question is, if you looked at this fraction, 4 over 24, could you reduce it at the very least?
Yes.
You could, right? You have to reduce the fraction if you can. That's right. So, like I mentioned before on this video, you could.
1 over 6.
Yeah, 1 over 6 is your answer, or negative 1 over 6. So negative 1 up here, 6 down here. Now let me give you an explanation on how to look at this. You could say that 24, you could rewrite that as 6 times 4. And then you could say, oh, I have a 4 down here, I have a 4 up here, the 4's cancel, and you end up with the negative 1 over 6. Does that make sense? You don't have to do that work. I'm just showing you how reducing actually works. So, side note. See, everybody knows that 4/8 is what? 1/2. Everybody knows that, right? But you could do this. You could say, okay, I'm going to leave this 4 up there, and the 8, I'm going to change this 8. I'm going to change it to 4 times 2. And because the 4 on top and the 4 on the bottom cancel out, so you end up with 1 over 2, 1/2. But see, we never actually do this. We just say, oh, 4/8, it reduces down to 1/2. It's totally fine. So I just want to show you how it actually works when you cancel. Okay, good question. How do you get a 1 on top if you already canceled the 4? When there's nothing left up on top, you have to put a 1 up there. Okay, you have to. But when there's nothing left on the bottom, you don't have to put a 1 on the bottom. For example, 3/9, and I think I already explained this on this video earlier, but 3/9, you could rewrite the 9 as 3 times 3. So you really have 3 over 3 times 3, and the 3's cancel. So you have to put a 1 up there and the 3 down there. Now you have to put the 1 because 1/3 is not the same thing as 3. But if you compare that to, like, let's say 12 over 6, okay? Whoops. 12 over 6. Now we already know 12 divided by 6 is what? 2, right? But you could rewrite the 12 as 2 times 6, and you have it over the 6 that's down here. So right here, the 6's do cancel, but you have a 2 left over up on top, and there's nothing left on the bottom. Do you have to write the 1 on the bottom? No, because 2 divided by 1 is still 2. So you don't need this divided by 1. When it's a 1 left over on the bottom, you don't need to write that. But if a 1's left over on the top, you need to write that 1 up on top. So I guess we never finished number 9. The final answer on number 9 will be 1 over 6x to the 3rd. And the negative sign that was up here on the numerator, I would just put it in front of the whole fraction, right next to the fraction bar. So I would write that as your final answer. That looks the best. You could leave the negative up on top, but I would write it out in the middle. Is there anything to distribute on the outside of the parentheses? No. So I don't even need the parentheses. So I really have the x to the 3rd, the y to the -5, and the x to the -8. So right here, there's different roads that you could take. You could apply different rules. What do you guys want to do? You want to do 3 minus 8? In other words, you're multiplying with the same base. So if you want to actually do these two, you could rewrite it x to the 3rd times x to the -8, and then bring down the y to the -5. Now, when we do multiply with the same base, that's rule 1, right? Rule 1 says you could add the exponents. So if you did do 3 plus -8, you get -5, right? So your new answer is x to the -5, y to the -5. Now remember, what rule is it? It doesn't even matter the number, but you can't have negative exponents. It's rule 6 up on the board. You can't have negative exponents. So you have to grab this one, move it down, grab that one, move it down, and they become positive. So your final answer is going to be 1 over x to the 5th, y to the 5th. 1 over x to the 5th, y to the 5th. That's your final answer right there. Number 11, same deal. Nothing to distribute from the outside to the end on the parentheses. So you're just going to rewrite everything without parentheses. P times q to the -2 times r to the -3. Okay? There are no like bases, so you can't add anything. You have to jump straight to moving negative exponents to the other side. So the p, it doesn't have a negative exponent, so your p is going to stay up there, and the rest moves down. Q to the 2nd, r to the 3rd, and that's your answer for number 11. Number 12. What's your answer going to be? 1 over 144, that's right. Anything with the negative exponent must be grabbed and moved to the other side. So there's nothing left up on top, and there's a 12 squared on the bottom. Remember, when you move it, the exponent becomes positive. So your final answer is 1 on top, and 12 squared. 12 times 12 is 144. 1 over 144 is your answer. So on the other video, I showed the little shortcut, which you could flip the inside fraction, make it positive, and then distribute. If you don't want to do that, you don't have to. Actually, I'll do 13 and 14 differently. 13, I'm going to do the little trick from the other video where you change that to a +2 and you flip it. So when I flip the inside, it'll become 7 over 3, and that outside -2 becomes a +2. That's the little trick I showed on the other video. So my answer will be 7 squared over 3 squared. That is 49 over 9. That's my answer for 13. Now, on number 14, let's say you don't like that trick. You don't have to use the trick. You could actually distribute the exponent to each and every term. So you could have 4 to the negative 4 over 3 to the negative 4. But then you need to follow the rule that says you can't have negative exponents. This one's going to go down. This one's going to go up. So you're really going to have 3 to the positive 4 up on top and 4 to the positive 4 on the bottom. Do they leave that as the answer on the back? Or do they actually work out 3 times 3 times 3? They work it out. So what's the answer on the back?
81
Over
256.
256. Okay, so if you do work it out, you'll get 81 over 256. But the shortcut is there available to you. What's the shortcut? If you have a negative exponent, you could take that fraction and flip it and make it a positive exponent and then distribute. Or if you don't like doing that shortcut, go ahead and distribute the negative exponent and then get your negative exponents and move them to the other side. Number 15, there's things that we could cancel. For example, we have 2 r's on the bottom that'll completely cancel out with 2 of the 3 up on top, and you'll have 1 r left. Sorry about that, it looks like a 2. You will have 1 r left up on top, okay? And what else could we do? We could take this negative exponent and we could move it up and make it positive, okay? Now, I still haven't moved it up and made it positive yet. I just circled it and drew an arrow. Now, in addition to that, the 22 divided by 11, that's really 2, and it's left over up on top. Another way of doing that is to rewrite 22 as 11 times 2. So if you rewrite 22 as 11 times 2, then you could clearly see how you reduce. The 11 up on top cancels with the 11 on the bottom, and there really is a 2 left over up on top. So let me write my fraction over. This is going to be my answer. Up on top, I have the coefficient 2. That's what was left over right here. And then I have a r to the 1, which I could just write as r, and s squared, which I'm going to write as s squared. Now I'm still going to move the s to the negative 3 from the bottom. I'm going to move it up, and it's going to be s to the positive 3. Now, what is left over on the bottom? There's nothing else left on the bottom. You could put the 1 on the bottom, but that's pointless because anything divided by 1 is the same thing. So what do we have as a final answer? We have the 2, the r, and the s to the 5th power. Again, you don't need to put it over 1. It's kind of a waste of time because divided by 1 is still 2rs to the 5th. So let's not put it over 1. It's just 2rs to the 5th. Let's move on. 16 is pretty fun. Has a couple of different rules we could apply. My favorite, easiest rule is anything to the 0 power is 1. So this w to the 0, you could just scratch it out. I mean, if you put a 1 right there, negative 15 times 1 is still negative 15. So I would just scratch it out and that's it. Then let's move on. What else? I could take anything with the negative exponent. I must move it to the other side and it'll become positive, okay? And even before moving, when I look at the coefficients, when I look at negative 15 divided by 5, what is my answer? Negative 3. And where's that answer going to be left over? Up on top, right? If you're confused as to where it's left over, this is the reason why it's left over up on top. 15, or negative 15, you could rewrite that as negative 3 times 5. Isn't that right? That's negative 15. So you don't need to look at that anymore if you have negative 3 times 5. And then you could say, okay, I have a 5 up here and a 5 down here. That cancels out. And that's exactly the reason why there's a negative 3 left over up on top. So my answer, let me rewrite my answer. It's going to be a fraction. There's going to be a negative 3 up on top. What else is up on top? Nothing else, just a negative 3. And on the bottom, I have the u to the 3rd that did not move. And I also have this u to the 1 that's going to be right next to it and positive, u to the positive 1. And right here I could still apply rule number 1, where you have u to the 3rd times u to the 1. That's really u to the 4th. So my answer is negative 3 u to the 4th. Now, I know I said negative 3 and I wrote it as positive 3. I want to take that negative 3 and instead of putting it up here, I'm going to put it right in the middle of the fraction, in the middle of my answer. So I want to put the negative right here. So there's my final answer, the nicest way it could look. Negative 3 over u to the 4th. 17, fun stuff. Again, you could cancel things out. d to the second up on top cancels with d to the second on the bottom. There's no more d's left. The d's are totally gone. Okay, and now after this, we could move things around. And even before moving things around, what do you guys think about this 8 up on top over the 4 on the bottom? What do you guys think about that? That's 2. And where's the 2 at? Is it on top or bottom? It's on top. So I could just say, okay, 8 and 4 cancels out. There's going to be a 2 left over up on top. Now, if you wanted to show your work and rewrite 8 as 4 times 2, and then the 4's cancel and there's a 2 left, that's perfectly fine. All right? It's up to you. So 8 divided by 4 is 2, and the answer is up on top. And then I'm going to move things around. I'm going to take this c to the negative 1, and I'm going to move it up right after the c to the positive 3. And then this f to the negative 3, I'm going to move it up. So let me rewrite what I have so far. And I'm going to rewrite by starting with what doesn't move. Okay, the 2 is still up there. The c to the third that's up on top stays c to the third. But I am moving the c to the negative 1. So I'm going to move it right next to the c to the 3, and it becomes c to the positive 1. And then also we have this f to the 4 that did not move. So let me just write it in black, f to the 4th. And let's also take this f to the negative 3, put it right behind it, right here. But I'm going to make it f to the positive 3 because we moved it from the bottom to the top. The exponent changes. Now, it is all over 1, which means that we don't need to write over 1. But let's do rule 1, c to the third times c to the 1. That's going to become c to the 4th. Let's not forget about the coefficient 2 that's out in front of our answer. And then f to the 4th and f to the 3rd, you add 4 plus 3, and you'll get f to the 7th. And that's your final answer for this problem, number 17. Number 18. Now this one looks like a multi-step problem, but you do know the easiest rule, the favorite rule, anything to the power of 0 is 1. And this whole thing is in parentheses. So this whole thing is to the power of 0, so the whole thing is 1. I mean, it would be pointless. Oh, I'm going to take this one and then move it down, take this one, move it up. I want to do y to the, like it's pointless. Because if the whole thing is to the 0 power, then the answer is going to be 1. So number 19, I am going to, is there anything I could cancel? I always like starting with canceling.
Yes.
Okay, so I clearly see the h's. I know that h to the third, 3 h's cancel out with 3 of these. There's going to be 2 left over. But then again, I do have this f to the negative 2, which technically I'm supposed to move down, right? But then this f to the negative 2, technically I need to move it up, right? But either way, it's cancel them because they're the same identical thing on top and bottom. So if you have 5 over 5, it cancels, it equals 1. 7 over 7, cancel, it equals 1. F to the second over f to the second, cancel, it equals 1. F to the negative 2 over f to the negative 2 cancels, it equals 1. Now the other thing I can do is apply the rule of negative exponents. This g to the negative 5, I'm going to move it up right behind the g to the positive 3, and I'm going to write it as g to the positive 5. And finally, maybe the first thing I should have started with is the coefficient 6 and the coefficient 54. If I think of this as a fraction, 6 over 54, could you reduce that fraction? Yes. What is your fraction reduced down to? 1 over 9, right? 1 over 9. So you could think of it as reducing, or you could also rewrite 54. You could say 54 is really 6 times 9, right? And then this 6 up here and that 6 down there completely cancel out. So that's how you end up with 1 on top and a 9 on the bottom. Either way, whether you think of reducing or whether you rewrite and cancel, it's the same thing. You end up with the same answer, 9 on the bottom and 1 on the top. Now, since I do have a mess right here, I need to start rewriting things, making it nicer. So let's rewrite our answer. Up on top, I have a 1, which I don't even need to write. I have a g to the third. Let me keep that in black since I didn't move it. It's still there from the original. And the g to the negative 5, I'm moving it up there. It's going to become g to the positive 5. And I still have the h to the second up there. And on the bottom, what do I have left on the bottom? Michelle?
What?
On the bottom, I have what?
Oh,
So there's a 9 left over on the bottom. And now the only other thing you could do is actually do rule 1, which says when you're multiplying with the same base, g to the 3rd times g to the 5th, that's really g to the 8th. H squared is still h squared over 9. So there's your final answer, g to the 8th, h squared over 9. Number 20. Now, keep in mind, the way I solve a problem may be totally different. Maybe you applied moving the negative exponent rule first before canceling out. I like canceling first. Maybe you could do a different rule. That's fine, right? But we should end up with the same answer. So how about this? Let's start with the coefficients. How about negative 12 divided by 2? What do you say the answer is? Negative 6. Where's that negative 6 at? Is it on the top or the bottom? It's on the top. So you could think of this as a division problem. Negative 12 divided by 2. The answer is negative 6, and it is on top. Or you could actually, if you wanted to rewrite the negative 12 as 2 times negative 6, and then you could see the 2's cancel, and you'll end up with a negative 6 left over. But anyways, negative 12 divided by positive 2, the answer is negative 6 up on top. What else could I cancel? There's a u on the bottom, and there's 5 u's up on the top. So one of the u's cancels out with one of those 5. You'll have 4 u's left up on top. And then what else? I could take any negative exponent and move it to the other side. So this t to the negative 3 is going to go up, and this t to the negative 1 is going to go down. We're going to switch them. And also, we're going to take this x to the negative 4 and move it down. Now, it's already getting really ugly, so let's rewrite what we have. We have this fraction. What's left up on top? Negative 6. Okay, so let's write that. We have a negative 6 up there. And after the coefficients, we dealt with t's, and we ended up switching them. So we end up with a t to the 3 up on top. Well, it became positive because we moved it. And then t to the 1 on the bottom, it became positive because we moved it from up here to down there. It becomes positive. And then the u's, we have how many u's? 4 u's left. U to the 4th up on top. And the x to the 5th stayed on the bottom. But this x to the negative 4th is going to go down to the bottom, and it's going to become x to the positive 4 down there. And I could, there's 2 more rules to apply. Do you guys want to cancel out t's, or do you want to add exponents right here with rule 1? Let's do both. Let's do both. Cancel, there's 1 t on the bottom, there's 3 on top, so you're going to have 2 left over up on top. And then when you multiply x to the 5th times x to the 4th, what do we get? X to the 9th. So my final answer is negative 6 t to the 2nd u to the 4th over x to the 9th. It gets easier once you practice. The more you practice, the easier it gets. 21 is a great problem to put on a test. We're going to apply 2 different rules. The first thing to do would be to distribute the outside exponent to the inside. I think that was rule 3, but then again, it doesn't matter what number it is. You're going to take this 3 and put it right there and right there. So
27r and r to the 3rd.
r to the 4th over, I'm just going to show my work, 3 to the 3rd, r to the 3rd. Now, of course, like you said, Alan, 3 to the 3rd is 27. So what we really have is r to the 4th over 27 r to the 3rd. Let me do that one in black. R to the 3rd in black. And of course, we could cancel out the r's on the bottom and on the top. So there's 3 r's on the bottom that cancel out with 3, so you only end up with 1 r up on top.
R over 27.
So the answer is r over 27. Great problem to put on a test. Number 22. Once again, we're going to apply different rules. Rule 3, where you distribute. And then the other rule of negative exponents, where you move them from one side to the other. Let's first start with distributing. I'm going to multiply and multiply. So on the bottom, I really end up with an m to the negative 4, an n to the negative 3. Are you with me? Yes. Now, after that, you realize that everything, this is an m to the negative 2, m to the negative 4, n to the negative 5, n to the negative 3, everything has a negative exponent.
You move it to the opposite.
Yeah, so you move everything, right? Move it to the opposite side. So this is going to go up, this one's going to go down, this one's going to go down, and this one's going to go up. So we're going to switch everything. So I'm really going to have on top the m to the 4 and the n to the 3. And remember, when we move them, we change the sign to positive. And then we take those original ones that were on top and we move them to the bottom and they become positive exponents. And now after that, we could cancel things out. There's 2 m's on the bottom that cancel out with 2 of these 4, so I have 2 left over. There's 3 n's up on top, and there's 5 n's on the bottom. When I cancel out 3 with 3, there's going to be 2 left on the bottom.
So m to the second over n to the second.
M squared to n squared.
M squared over n squared is the answer. M to the second over n to the second is the answer. Once again, distribute and then worry about moving negative exponents and worry about canceling. So I'm going to distribute the negative 4 to each of these exponents, which means I need to multiply them. So I will have j to the positive 4, k to the negative 12 over the bottom j to the third, k to the third. Now I'm going to cancel things out. I have 3 j's on the bottom that are going to cancel out with 3 of these 4. That means I have 1 j left up on top. And then this k to the negative 12, I'm going to move it down. It's going to become k to the positive 12. So let me start writing my answer here. I still need one more step. I have a j left over up on top. The k to the 12 moves down. My k to the 3 is still down there. And the k to the 12, we said, moves down and becomes positive 12. So my final answer,
J over k to the 15.
j over k to the 15. Number 24, I'm going to distribute the outside exponent to the inside. So that negative 3 needs to be distributed to that 2. So I will have 2 to the negative 3. The negative 3 distributed to that power of negative 2. So you have to multiply power to a power. You will end up with a to the what? What's negative 3 times negative 2? Thank you, positive 6. And then the negative 3 distributed to the b. And the b will have a negative 3 power. Now on the bottom, I'm just going to rewrite it for now. And I wrote that in black because nothing changed from the original. I just rewrote it. Now after that, I could choose to apply different rules. If I wanted to move negative exponents down, I could do that. But I, for some reason, like starting with the canceling rule. I have 2 a's on the bottom. I have 6 a's up on top. So both a's on the bottom completely disappear. How many are left up on top? 4. Right? So 2 cancel with 2 of the 6. Now there's 4 left over up on top. What else? I'm also going to take, now I'm going to move the negative exponents to the other side and make them positive. So this 2 to the negative 3, I'm going to move it down right in front of the 5, and I'm going to have to multiply it. And then this b to the negative 3, I'm also going to move it down right after the b to the 4th, and I'm going to have to multiply them. So let me show what I have so far. Up on top, if we look at this move down, so it's not up there anymore, I have an a to the 4th. So I'm also going to rewrite what I have left on the bottom. But then again, I still need to move the negative exponents, the 2 to the negative 3, I need to move it down in front of the 5 and make it positive. So I'm going to put 2 to the positive 3 right in front of the 5, and I know I need to multiply it by 5. And also, I need to move down this b to the negative 3 right after the b to the 4th. So I'm going to have b to the positive 3 right after the b to the 4th. Is everybody with me so far? And now after that, I'm going to do whatever math I can. Notice on the bottom, I have b to the 4th times b to the 3rd. That's rule 1. So we need to add the 4 plus 3, and we're going to end up with b to the 7th. So this right here, b to the 4th times b to the 3rd, that's going to be b to the 7th. Let me circle it, and I'm just going to put b to the 7th. So instead of b to the 4th times b to the 3rd, I'm going to rewrite it as b to the 7th. Let me rewrite my whole answer so far. And on top, we have a to the 4th. On the bottom, 2 to the 3rd. Could I do 2 to the 3rd? What is that? 8. So 2 to the 3rd is really 8. And what is 8 times 5 on the bottom? That's 40 on the bottom. And we also have that b to the 7th on the bottom. So there's our final answer, a to the 4th over 40 b to the 7th. Number 25, hopefully you changed the typo that I had on there. Let's focus in on this one. This is 25. Now, we could work on the inside of the parentheses, which is what I like to do. If you could do anything in there, I recommend doing it first. Or you could also, if you wanted to, distribute the outside -5 to the inside ones. And there, like I said, there's so many different ways of doing this. You could even change this -5 to a +5 as long as you switch everything. But then again, you have negatives on the inside. So how about this? I'm going to go with rule 3, distributing the outside exponent to each and every inside exponent. The only reason I'm choosing to do that is because I know that some of them are negative. And when I multiply a negative times a negative, they become positive. So let me do that. Let me distribute -5 times 1. We're going to end up with a q to the +5 up on top. And then -5 times 3, that's going to be an r to the -15 on top. And on the bottom, when I distribute -5 times 1, that's going to be q to the -5 on the bottom. And when I distribute -5 times -2, that will be r to the what? 10. And now from there, I'm going to use the rule of negative exponents. I need to move them to the other side. So the q to the -5 is going to go up right in front of the q to the 5, and I'm going to have to multiply them. And the r to the -15 is going to go down. It's going to become +15. Then I'll have to multiply it with the r to the 10. So I like to first rewrite what does not move. So the q to the 5th did not move, and the r to the 10th did not move. Now, the q to the -5 is going to go up. So I have q to the -5 that actually becomes +5 when you move it. So you don't have to put the positive. You could just write q to the 5th. And the r to the -15 that was up on top moved down to the bottom, and it becomes r to the +15. And what we have left over is a fraction that we could apply rule 1 on. So q to the 5th times q to the 5th is q to the 10th. Rule 1 says you add. And r to the 10th times r to the 15th is r to the 25th. You have to add exponents. And ladies and gentlemen, that's your final answer. Q to the 10th over r to the 25th. Number 26, once again, you could work on the inside and then distribute the outside exponent to the in. Or you could start by distributing the outside exponent in. What do you guys want to do? On the other one, we distributed the outside exponent to each and every term on the inside, then we move things around. Just to be a little different on this one, let's work on the inside. On the inside, is there anything that I could cancel? Is there anything I could cancel on the inside? There's a d on the bottom that could cancel with one of these 3, and I'll have 2 left over on top. Right? What else on the bottom? I have c's, but I don't really want to cancel the c's yet. This one has a negative exponent. So what I'm going to do is take this c to the -3 and bring it down right in front of the c to the 5th. Okay? And I'm also going to take this, might as well, take this h to the -4 and move it up and make it h to the +4. So let me rewrite what I have inside of the parentheses. So inside of the parentheses, I have a 7 up on top. The c to the 5th was on the bottom. This c to the -3 moved down and it became positive, so I have a c to the +3 on the bottom. The d canceled out on the bottom, but I still have a d squared up on top. And the h to the -4 on the bottom moved up and it became h to the +4. I still have the parentheses, I still have a -1 on the outside. Now, I'm still working on the inside of the parentheses. On the inside of the parentheses, what could I do? Is there anything else to cancel? No. But what could I do? What other rule could I apply on the inside? C to the 3rd times c to the 5th. What is that? C to the 8th. add exponents. That's rule 1. So c to the 3rd and c to the 5th, that's c to the 8th. I could scratch it out and just rewrite it as c to the 8th. So let me take what I have right here and rewrite it all. And now from this point, you could choose to distribute this outside exponent of -1 to each and every term, which you know is going to have all negative exponents, which you're going to have to flip everything. Or you could do that little trick I showed you on the other video, that you could make this exponent a positive as long as you just switch everything on the inside. So I think the shortcut works a little bit better. Make this -1, make it a +1, but by moving the numerator to the denominator and the denominator to the numerator. So if I did do that, I'd have the new fraction c to the 8th over 7d squared h to the 4th, and that becomes a +1 power. Now the +1 power doesn't change anything. So that's your actual answer. Your answer is c to the 8th over 7d squared h to the 4th. That's your answer. Now, did you have to do it this way? Heck no. There's like 15, 20 different ways you could have done this. You could have applied different rules first, but you should end up with the same exact answer, c to the 8th over 7d squared h to the 4th. Final question, number 27. So what do you think would be a wise move? To start by distributing the -2 to each and every term? Every single term, distribute the -2? Or would it be better to work on the inside and do anything we can on the inside? Inside, okay. So what could we do on the inside? Cancel what? The x's and the y's. Okay, so x to the 3rd up on top, all 3 x's cancel out with 3 of the 4. You're going to have 1 left. Are you with me? How about the y's? There's 1 y on the bottom that'll cancel out with 1 of these 2, and you're going to have 1 y left up on top. Now the z's, I can't really cancel yet. I mean, I'm supposed to get that negative exponent and move it up and write it right behind that z and then multiply. But it'll become z to the +2. So far I've done a couple of things. Let me rewrite what I have on the inside of the parentheses. So on the inside of the parentheses, I still have the 2, I still have the 3, but the x's that were on top are no longer there. The x's are now only on the bottom, and it's x to the 1 power. I'm just going to write x. Now the y that was on the bottom is no longer there. It canceled out, and I have a 1y left up on top, a y to the 1, but I'm just going to write it as y. And we said that the top z, we left it alone, but the bottom z, this one, went up. So I'm going to put it right there, right next to it, but it becomes a z to the +2, and I need to multiply it with that z. Now let's not forget that this whole thing still has a power of -2 on the outside. But working on the inside, we still have this z times z to the 2nd. What is z times z to the 2nd? Z to the 3rd, right? So z times z to the 2nd, that's really z to the 3rd. So I'm just going to scratch it out and replace those 2 with the z to the 3rd. So one more time, let me rewrite everything. And now at this point, you could distribute the outside exponent to each and every term, but you're going to end up with all negative exponents, which means you're going to have to switch everything. So you could do that little trick I showed you, where you take this -2, make it positive, as long as you take the numerator and the denominator and flip them. Okay, so that's what I'm going to do. I'm going to change the -2 to a +2. How? By flipping the inside fraction. And now I'm going to distribute that outside 2 to each and every term on the inside. So when I distribute that outside 2, on the 3, it'll be 3 squared. On the x, it'll be x squared. On the bottom, that'll be 2 to the 2nd. On the bottom, it'll be y to the 2nd. On the bottom, it'll be z to the 6th. So that's our answer, but the only other thing we could do is the 3 squared is 9, and the 2 squared is 4. So for my final answer, I will have 9x squared over 4 y to the 2nd, z to the 6th. I think that's the longest video I've ever recorded. But it does have every single question on the Homework Explained. That doesn't mean I want you to watch everything. Just fast forward to the ones you're having questions on.